All good? Okay, to talk about Web3, we have to talk a little bit about the history of the web. And the history of the web matches with my history. I have this young face, but I'm an OG guy. I've been developing since 2000. And but how was the web? Like we have these divisions, like Web 1 is the beginning of the web, where we have like a very simple web pages, basically pages with hyperlinks that connect one page to the other. Basically, very, very basic static in web pages. Then we have the Web 2, where we start to have like dynamic generated content, CMS, blogs, social media, so on and so forth. And they were all hosted in centralized servers. On the Web 3, we're going to have some concepts, a lot of concepts, new concepts. The main one that I would emphasize, it's the decentralization. That is, we don't have anymore one central entity. We have a network with nodes around the world, and people can join whenever they want. We have cryptocurrencies, we have NFTs, DeFi, DAOs. There are a lot of topics that today, unfortunately, it's impossible for me to go deep into them. So today I'm going to focus more on the blockchain. That is the backbone of the Web3. And all these concepts, they are possible because of the smart contracts. Smart contracts are nothing more than code that we write and we deploy them into the blockchain. And in the blockchain, we have virtual machines that will run this code as soon as people interact with it or other machines interact with it. So if we could talk about like the basics of Web3 on A, B, C, D, Web3, the A for me, it would be autonomy. Like we got rid of the middleman. We don't need an entity, a central entity to do things. We run in a blockchain, in a network that is open, and you don't have to ask permission to do things. Blockchain. What is the blockchain? Blockchain is a distributed ledger where you have blocks that are connected each other, forming a chain. Like if you have a block that is connected to the previous one, in one block you have all the transactions that you have in this block. You have a nonce, you have the hash of this the previous one. So that's the reason it's called blockchain, chain of blocks, because the second one always have the hash that has the content of the previous one. So there's no way for you to change data or to inject some malicious code into the blockchain. And as we don't have the middleman, the central entity, we have to find a way to allow the network to work, and we use code to do it. We use cryptography to do it, and then it ensures like the integrity and the security of the network, making it resistant to tampering and fraud. And the decentralization, again, that is the main topic. It's to spread the power, not only one entity. Like we have many actors that can join and participate openly. When we talk about security and privacy in Web3, there's no rollback. It means if you write on the blockchain, you cannot change the data. You cannot delete the data. As I explained, you have blocks that are mined one after the other, and you have a chain. So there's no way to change the data, because if you change the previous data, you change the whole sequence of blocks. So if you write there, it's there. And there's no at all free to call as well. Just like we grow up, we make mistakes, and we have to deal with the consequences, right? With great power comes great responsibility. And it is the aspect of decentralization and permissionless, what it means to be permissionless. You don't have to ask anyone to transfer money. How many times you want to transfer money to your friend and the bank was out, or you have to wait until the next day? On the blockchain, there's nothing like that. It's 24/7. You transfer the amount you want, and you don't have to ask anyone to be part of the network. You can have your computer. Sometimes you have to have a special hardware to run it. You install a software, and you're part of the community. You're part of the blockchain. And then we have the trustless concept. That is, we don't have to trust anyone. You can verify everything that is on the blockchain, because a blockchain, we have private and public blockchains. Today, I'm going to talking just about the public ones, where anyone can go and verify everything. So you don't have to trust. You can go there and check all the transactions, from whom was sent the transaction, the amount, and everything that happened. It's open to anyone, inspect and verify. Okay, Kadu, and now everything that I learned on Web 1, Web 2, now you come with Web 3, so I have to learn everything from scratch? Not exactly, because the challenges, they are according to each one of the development of the web. For example, on the Web 1, we had like limited design capabilities, right? These not many colors. We didn't have like CSS properly. We didn't have JavaScript, so we didn't have like interactivity and no standards. So everyone who was developing in the beginning, not many people, mostly companies, they were building almost the same type of things, because you didn't have standards. Then we have the Web 2. So things start to get more exciting, right? JavaScript frameworks, jQuery, pop-ups everywhere. But with this, we increased it a lot on the front-end side, the bundle size of the page. So we had to download a lot of stuff like web fonts, a lot of CSS, a lot of JavaScript. So the performance was compromised as well. And with this, new APIs, new user-generated content, we have some issues like cross-site scripting, cross-site request forwarding, yes. And on the Web3, the decentralization, at the same time, it's a good thing. But as we have now distributed nodes and machines running, if we adopt one blockchain, because we have many blockchains, it's not like JavaScript frameworks that every second you have a new one, but people are building, because we are like in the early stages of the Web3. So companies, people are building, trying to solve the issues that we have today for enjoyment tomorrow. So for example, if you launch your product in one blockchain today, tomorrow, if you want to change to another one, you have to deal with a lot of stuff. They are trying to solve this issue, but it's a challenge. The user experience, in my opinion, it's just like the web at the beginning, you know? It's not pleasant at all. Some websites, like the developers, they don't care. It seems that they don't care much. You don't know what is really happening, because you have to identify yourself. I'm going to show later on. With a wallet, you have to confirm the transaction that the application will take, for example, funds from your wallet to pay for the transactions, because as we don't have the middleman, someone has to pay for the fees so the network can work, right? Nothing's for free. And we have the issue of actually is a blockchain they call trilemma. it's kind of a triangle like this. When you have the scalability, you have the security, and you have the decentralization. So the blockchains, they are in or here or here or here. It's just like if you want to build a software, it can be good, it can be cheap, and can be fast. So there's no, you have to find, each blockchain will focus in one of these aspects and solve different problems, different issues. Um, okay, and it's nice, it's a new technology, it's the revolution. Why do I call revolution as well? Uh, because for me, we are talking about not only new applications, right? We are talking about a new financial system. That is for me is the main thing, and it's a permissionless. So anyone, for example, if you try to open a bank account, I'm an immigrant here. I used to live in Ukraine. The war started. I came to open a bank account here for me. It's difficult. On the Web3, I create a wallet. I'm there. I don't have to show my ID. I don't have to show anything. I just open my account and I'm part of the network. Uh, so if we take, I took like the three, the five biggest big techs and see how is the market cap of them today. Like Microsoft, Nvidia, and Apple, it's around $3 trillion. On the blockchain, Bitcoin, that is the biggest one, is just 1.3. What it means, there's a lot of opportunities for us to build things and to enjoy these opportunities. But it's an interesting thing. It's, for example, the difference between the Microsoft, Nvidia, and Apple, for example, is almost 3 trillions. But if you take Bitcoin for the second one, that is Ethereum, it's less than half. And then from Ethereum to Tether, it's 4 times. It means there's a lot of gaps that has to be filled by projects, by you, that you build things to solve the issues that we have to build. And who is already taking risks, right? Because as I said, we are on the early stage time, so things don't work the way you expect they're going to work. We have to build the tooling, we have to build this, and sometimes starting from scratch, build again and again and again. So I think you guys can recognize these companies. I just added this Tencent here. It's a Chinese company, but it's a $3.5 trillion company. So I think it's a big one to be part of this group. Any doubts so far? Okay, I will try to, I have a little demo so you guys can understand better what what is a decentralized application, because applications on the blockchain we call dApps, decentralized application, because they run on the blockchain that is a distributed and decentralized network. To participate and to interact with the blockchain, you have to have a wallet. A wallet will identify you on the network. So you have an address that recognize you, because if I want to send funds to another person, or if I want to interact with a contract, I have to have my own address to do it. And here I have this MetaMask that is the most famous wallet. It's a extension that you can install on your Chrome, Edge, Firefox, whatever. And here you can choose, because as I said, we have different issues, different problems, and different companies uh, coming up with solutions to solve different problems. So you have different blockchains. The most common one, like that people are developing, is on Ethereum. And here we have the main nets, where we used to call them the main nets, that one that is in the production, let's see, the production environment. But we have like a staging environment as well, and they used to call it test nets. So the Sepolia, it's a test net for Ethereum. So this is the one where we're gonna deploy this application, and we're gonna interact with it with a simple front-end application, so you guys can understand better how it works. Okay, I have here, because in the same wallet you can have different accounts, right? So here I have three that I'm gonna use today, just to demo the application. First, I'm gonna open here. It's a very simple application that I've built uh, in June 2022 for a hackathon that I participated. Because as I told you guys, I used to live in Ukraine. When the war started, I came to Portugal and I was not feeling well. As you can imagine. So I decided I cannot work, I cannot do much stuff. So what can I do? I can study, because I know that this I can use later on. So that's what I did. And then I started to study about blockchain, and I got into this hackathon, and I developed this hack list that is a very simple application where you can you create a hackathon and you define how many hackers you want to participate in this hackathon, and the hackers will come and apply to this hackathon. Very, very simple. And then I have here two applications, like the backend part, that is the smart contract that we're going to deploy to the blockchain. And then we're going to have the front end as well, that is a Next.js application that uses nothing special from Next. It's just like, because at that time I was using Next, but it's a React application, basically. So here, let's just take a quick look in the contract so you guys can have a look. Solidity is the language where you can develop smart contracts on the Ethereum virtual machine. So here at the beginning, you define the version that you want to use. Here's the name of the contract, some variables, for example, the number of the addresses, the max number of addresses that I'm going to allow, and then a mapping where I'm going to put all the hackers that I want in this specific hackathon. So for each hackathon, I'm going to deploy a new contract. And here I have the constructor where I can set how many hackers I want in this specific hackathon. And here, a very simple function just to add the hacker into the mapping. Here I do some checks to see if the user is already in the mapping. If I check here as well, if the user if the list is already full. And here, if it's not, I can pick, because on the blockchain, the user, through the wallet, it interacts with the contract. So with this message sender here, is the user who is connected to the blockchain interacting with my contract. So I can know the user address, and then I can save it here. And here I increase the list. It's a very basic contract. And here I have a simple script as well to deploy the contract to the blockchain. Just out of curiosity, like we pick here the name of the contract. Here we just log that we are deploying. And here I call the method deploy of this. I'm using this hard hat, that is a framework for working with smart contracts. And I can define how many hackers I want for this project that I want to deploy. And then in the end, I have the contract, because as soon as you deploy your application, your contract on the blockchain, you have an address that people can interact with it. Okay, so let's go here. And then I have here on the README is just later on, I will share with you guys this project as well, so you can run. I will not like install the dependencies because I did it already, otherwise we're gonna lose time. But here I just gonna run this script to deploy the contract. So that is the previous one here. Okay, let's see. And here I configured my set up to deploy this on Sepolia. As I told you guys, you can choose whatever blockchain you want. And if it's a, we used to call EVM compatible blockchain, for example, Polygon, Arbitrum, Optimism, different blockchains, they are EVM compatible. So this same smart contract I could deploy in different blockchains. I just had to change some parameters and that's it. So my contract is deployed into this address. So I'm just gonna copy it here and then I'm gonna close this. This project is over. Here I have an environment variable where I have to set the contract address because my front end, oops, my front end has to know with whom it's gonna talk to, right? And that's it. So I'm gonna here to the front end. I installed already the dependencies. So I'm just gonna run npm run dev. Okay. And then in the browser, let's see if I'm connected. No, okay. Okay, what is happening here? I'm running the application. So my application already detected that the user has the extension, it means the wallet installed, and it's asking me to identify myself. So as I have a lot of accounts here on my wallet, and I'm using here the Sepolia is connected already to the Sepolia blockchain, I can choose which account I want to interact with this platform right now. So I will start with this dev, this first account. Okay, confirm. Okay, so here it's a dynamic task that I can check. Do you guys remember we deployed the application with 2 hackers that can join my hackathon, right? So we have 2 spots available, right? So I can come here and I can apply. And then what is happening here? Here it's saying, okay, you is this guy, you are interacting with this contract. You see contract interaction. It means I'm calling a function from my contract. I will show you guys later on in the code this call, but just for you guys to understand how it works. And then here it shows like the fees that I'm gonna pay. So I know upfront how much I'm gonna pay for this transaction. And sometimes depending on the traffic on the network, you're gonna pay higher or lower. It depends. But then I can confirm or I can reject. In this case, I'm gonna confirm. And the time of the transaction, what is happening under the hood here? I'm sending a transaction to the blockchain and the nodes are validating it. And then I'm gonna receive a receipt of this transaction. And later on, I can check on the blockchain explorer. I will show you guys what is going on. Okay, I made it. I managed to interact with the contract. I pay the fees for the transaction. My transaction is already on the blockchain. Nobody can change it. Okay? Okay, so now what I'm gonna do, I'm gonna simulate here like if I was another user interacting with the blockchain. So I will pick this dev2, okay? I pre-funded, as you guys can see, some funds on these wallets. Otherwise, I will not be able to do these transactions, right? Uh, so I'm here on the second one. I would just reload the page. It's gonna ask again, so I'm gonna log in with my dev2 now. Confirm. Okay, so now my contract knows already there is someone on my list. Do you guys remember I showed you the mapping? I added the first one on the mapping, so now I have only one spot free. Okay, I'm gonna apply. The fee again, you see 27 cents. Confirm. And that's it. Sometimes it takes longer, sometimes it's faster, especially when we talk about a test net. Sometimes it's broken. and you think there's some error on your code, and no, it's on the blockchain. So bear with me. You have to be resilient. Okay, I made it. So I cannot add anyone on this smart contract because I defined that only two could participate, right? So if I come here, if I try to connect another user, for example, the dev3, and I try to access the page, the application, it should not allow, okay, I'm late for the party. It's over because this contract I deployed and I said that only two people could join the hackathon. That's it. Let me just show very quick. Do you guys have any question so far so good?
If I want to cancel the party.
If you want to cancel the party?
Yes, I am one of the hackers in hackathon and blockchain contract cannot be changed. In this specific situation, I want to cancel my participation in such perfect party.
Yeah, the thing is, the way as I showed, like the contract is very, very simple. We have only one function that to add people. If yes. I want to take out people, I could create a new method and I will take the index from this specific user from the mapping. I could do this, but this is just like to show a very simple application. But you could do.
In blockchain, it works like block after block after block.
Yeah.
So it's like the new block of removing some person from the smart contract. Yes.
Yes.
It's also block.
Yeah, because the thing is, it will be a new transaction. Yeah. So you can have a state in the blockchain. As I created these variables here in the contract, let me open here so I can explain better. You have this mapping here, this mapping, you see? So I can add things in the mapping and I can take things from the mapping. But each time I change this, it's a new transaction. So it's there. It becomes part of the ledger of the history. So yes. Exactly, exactly. It's all there for anyone go there and inspect and verify.
Like git reverse, you see it in history as your opposite commit, as it were.
Yeah, you cannot really revert, but you have the transaction there. So you're gonna see I'm gonna show here on the blockchain explorer, you can see the call to this specific method here that is add to hack list. And if I had one removed from the list, you're gonna see a call to this specific method from this wallet to this contract. It's all there in the blockchain to anyone go there and verify.
So for an analogy, it would be a string of different kinds of git commits that you could not change.
Yes. Yes,
that's
exactly.
Git revert. So yeah. If you want to remove a git commit, you can't revert it. If you want to put a new one in, you
yes.
have all the history.
Yeah, yeah. You cannot revert. Yeah, you can always put on top of it, but you cannot delete from or change something. Yes, I will show here because if I pick here the contract that we deployed and here I'm here like on this Sepolia Etherscan that is kind of a blockchain explorer, just like you have Finder, Windows Explorer, you have for the blockchain for all transactions in the blockchain. So I picked here the address of my contract. So you have all the transactions. We made 3 transactions here, right? So the transaction creation, because I deployed the contract. This is the first one, right? And you can see here 8 minutes ago. Then I had the first user in the blockchain. Let's open this so you can see the method call. Here you see like the user address, my contract address, and then the amount and the time and everything from the transactions. That's here is just the original the data. So anyone can come here and see what is happening, and I could even interact with my contract using here. here I didn't really verify the contract, but I could, if I verify the contract from this Explorer, I could call all the methods in my contract. I just connect my wallet here, and then I would call each method. Okay, and in the blockchain, when you write to the blockchain, you have to pay fees. If you are reading, you don't pay. Okay. Um, something else?
There's a lot of questions, I think, right?
Please.
Please.
It's time to help the people that are remote. It's team.
Thank you. Uh, as you said in the first or second slide, I think you express like a blockchain is like a distributed ledger. It's like a database, so we can imagine that when you make a transaction to the blockchain, you are making a transaction to a database. Sorry. Then, what's the point of paying fees? Because, for example, if I have like an SQL database on a server, I can just send a transaction and it gets atomically executed and so on. So what's the point on paying fees on a blockchain?
Yeah, the thing is, nothing's for free, right? Just like that. The thing is, in reality, nothing's for free. And the idea to have a blockchain that can be run by anyone is to make it accessible to anyone who wants to participate. And but to keep this network running and secure, you have to have some actors participate on it. If you don't have incentives, why they gonna work on it? So that's the reason. When you do a transaction, you have to pay fees for the ones who are maintaining the chain, maintaining the network. That's the reason to pay the fees. Exactly. And yeah, we could say, yeah. Yeah, it's a way to incentivize people to join the blockchain and to be rewarded for it, right? Because depending on the blockchain, you have a different type of consensus. That is a way to validate the transactions. You have the two most common ones. It's proof of work. For example, on blockchain, Bitcoin blockchain, it's proof of work. Ethereum used to be proof of work as well, but now they change to proof of stake. In both scenarios, people who are validating the transactions, they are rewarded for it because they are or spending hardware, or they are putting their tokens to validate the transactions. In one way or the other, they have to be rewarded. Otherwise, there's no free lunch, right?
They won't do it if they don't give you one.
Exactly.
That's why they're
And even better, like, because they can choose which transactions they're gonna earn more, right? If you want to if you run a company, you want to make profit, you're gonna choose the ones that is better for you, that you're gonna spend less and earn more, right? So when you send a transaction to the blockchain, you can pay more, so your transaction will get mined faster, right?
During
That's
development, does it not work out to be expensive?
Sorry.
During development, when you're just practicing,
That's the
it's
thing.
not expensive.
That's the reason we have the test nets. Just like,
Pay for it.
no, the thing is a fake money. Yeah, we used to call them, like, you have a thing called faucet, where you have this free money that's a fake one that you can use, and that's it. You don't pay. Yeah, because otherwise it would be very very expensive.
As far as I understand, smart contracts can interact with other smart contracts, right? And since every transactions cost money, I bet there is a possibility of some bug exists and which can lead to overspend. So, or at least if they're gonna be too many transactions, we're gonna spend too much. So, are there any techniques to save some to reduce the costs, or I don't know, to just prevent overspending?
Yeah, there's a lot of ways for you to optimize the transactions as well, and you can have some oracles or some relays that can, for example, pay for the transactions to the users. It's kind of a new concept, but we have um, proposal that is you can, for example, you have a game, right? And you don't want your users to pay every time they collect something inside the game. So you can, as a company, as a the game creator, you can put some money in the smart contract in a relay, and every transaction that happens inside the game, it's gonna be paid by this relay. You know, so people can enjoy the game, and but in the end, someone has to pay because for the transaction to be in the blockchain, someone has to validate, and it's a work, and it has to be paid, right?
Does it reduce decentralization? Those oracles and relays?
uh, it depends. It can reduce, but sometimes it can be more expensive. But it's a business model as well for you, right? If you want to more traction, let's say, or if your model can sustain this kind of activity, you can pay at the beginning, or you can pay for some specific users, and the others will pay. And it will depend on the business model of your application.
You can control the spending through the sole language itself, though, can't you? If I remember right,
Sorry?
can't you put limits on if it has to reach a particular threshold before you decide to actually let it go through and spend it? If I remember right, through the language.
Yes.
Yeah.
You can put like a guess. And you, when you as a user are going to confirm the transaction, you can define if you want to accept or not, and if you want to pay a little bit higher price, your transaction will be mined first. But if it's a smart contract, you can define as well in the relay, depending on the relay you are using, like the limits for each transaction.
Guys, next question. No, we can do the two. I think it's fine.
Okay, so let's say I picked Ethereum for making my Web3 application, and then with time, the blockchain itself became expensive and transactions are very costly. So, is there a way for me to continue using this blockchain, or will it eventually become not possible if the blockchain is too expensive? And if there is no way, if there is a way, is there a way to also switch, for example, to a layer 2 solution? For example, for Bitcoin, you have the Lightning Network, and I believe Ethereum switched to the proof of stake because of the same reason, the cost of the transactions. But let's say I wanted some uh, proof of work solution. Is it possible to continue with application with an application in the same network?
Yeah, when you have on Ethereum, for example, you have Ethereum EVM compatible blockchains. For example, Polygon, Optimism, Arbitrum, and so this same contract that I deployed on Sepolia, that is the testnet for Ethereum, I could deploy on Mumbai, that is a testnet for Polygon. Not big deal. It's exactly the same. I just change a configuration there that instead of deploying on Sepolia, deploy on Mumbai. And the cost is on the, as you said, we have what we call layer one blockchains, that is Ethereum, Bitcoin, and we have on top of it other blockchains trying to solve issues about scalability as that triangle, that the trilemma, or scalability or decentralization or security. We have Polygon, we have Arbitrum, that is layer 2 blockchains, but they are on top of Ethereum. So they use the security and all the infrastructure of Ethereum, but in another level.
So will I still be able to migrate all the data, all the systems that I had on one blockchain to another?
The data will be on that blockchain, right? So it's not possible for you to. As I said, like it's a block, so there's no way to change it. If it's there, it's there. If you want to migrate to another blockchain, it will start over. But of course, you have ways to, for example, compensate people who has a history on your previous blockchain. You do what we used to call like a snapshot. So from this time, you say, okay, 10 people used my blockchain. So I will reward these 10 people with 100 token on my new blockchain. This happens. And there's a thing to incentivize you guys that is called airdrops, that they do exactly like this. They are launching, or you are launching your new application, your new DApp, game, decentralized exchange, or it doesn't matter. People will start using it, even on a test net. And then when you're gonna launch it, you do a snapshot. Okay, people who used my application from this time until this day, I will reward them. And some airdrops, they are very, very good, you know? So it's an incentive for you to use these new platforms as well and make some money. Who doesn't like it, right? Because, oh, next one. Who? Okay.
So the information on the blockchain, okay, we are understood that that's there forever. So you use those accounts to register for the hacking contest. So what kind of information can we get for the real person that is using the blockchain? For example, can you get the person's name, real name, or whatever?
Yeah, you can have different types of information. You can have integer, you can have string, you can have different types. That will be just like you save in a database, you have different types. On the blockchain, you have some different types as well. It will depend on the desire and of your application. Sorry? Yes, yes.
So with that address, is it possible to identify that you are the owner of that wallet?
Uh, yeah, the thing is, the wallet is the way, is your identification on the blockchain. You can have multiple, as I showed you, dev 1, 2, 3. So every time you interact with the blockchain with one address, that is your identity. So your history will be attached to this address. If you use another one, it will be another one. So every interaction you do with a contract or you send money to another wallet, it will be related to this address.
What about China
can
and
link
see
the
and see
person
that
to the wallet.
and see yeah, that's it.
You can link the person to the wallet. Like who is doing
Oh,
that?
okay.
Could you look at transaction history and say, oh, that address is me. Oh, I
Yeah.
know where he lives. and
The
it's
thing,
me."
the thing is, you could, for example, when we talk about coming from the, we used to call the fiat word, that is the dollar, euro, whatever, to the blockchain, you have to use something like an exchange to exchange the fiat money with the digital money, Bitcoin, Ethereum, whatever. And in this centralized exchange, they are just like banks. When you go to a bank to open a bank account, you have to give your mother name, your dog name, whatever, right? It's the same. They're gonna ask you the same shit. So they can connect you to the address. But I could come here, I could open a new wallet on MetaMask, and I'm in. I just have to send funds maybe from another wallet to this wallet. There's no way to, connect me to anything. That's the privacy that you have. That's it.